Welcome, everyone. Today, we are taking a journey to discover a real-world superpower. And no, we aren't talking about comic book heroes flying around in capes. We're talking about a literal superpower that scientists and policymakers are using right this very second to save the planet. In this explainer, we're going to unpack exactly how this incredible technology works, step by step, and see how it tackles some of the absolute biggest environmental challenges of our time.
Okay, let's dive into this. Imagine for a second what you could do if you had the ability to see the Earth's changing health directly from space. We are talking about having actual X-ray vision to look through heavy clouds, the ability to see heat that is totally invisible to the naked eye, and the power to predict the future of our environment before disasters even strike. It sounds completely like science fiction, right? But it's very real, and it relies on something called spatial thinking, which is really just understanding the relationships between different geographic locations.
So that real-world superpower has a name. It's called a Geographic Information System, or GIS for short. At its core, GIS is a technological framework used to capture, store, manage, and visualize spatial data. But to put it simply, it's the integration of geography, plus data, plus analysis, plus visualization. When you bring all of those elements together, you get the ultimate tool set for understanding massive environmental problems. Whether it's climate change, deforestation, or flood risks, GIS maps it all out by layering information to find these brilliant hidden patterns.
So how exactly does this whole system work? Well, I want you to think of GIS kind of like baking a cake. There are 5 essential components. First, the hardware, things like computers, servers, and GPS devices. That's your oven. Second, the software, like ArcGIS or Google Earth Engine. That is your recipe book. Third, the data, your spatial data sets. Those are your raw ingredients. Fourth, the people, the analysts and researchers. They are the bakers. And finally, the methods, the analytical techniques. Those are your specific baking techniques. You need all 5 of these working perfectly together to get a good result.
And this brilliantly illustrates the data part. When we handle those digital ingredients, GIS data usually comes in 2 main flavors, raster and vector. Raster data is essentially a grid of pixels. Think of it like zooming all the way in on a digital photograph. Each little square pixel holds a value, which is perfect for mapping continuous things like temperature or elevation. Vector data, on the other hand, is basically like playing connect the dots. It uses specific points, lines, and polygons to draw exact shapes on a map, like a point for a weather station, a line for a winding river, or a polygon for the borders of a sprawling forest.
Now, you might be wondering, where do we actually get all these incredible spatial ingredients? Well, a massive amount of it comes from right here. Satellites in orbit. These satellites are literally our eyes in the sky. Through a process called remote sensing, they act almost like a doctor's X-ray machine. They collect the vital signs of our planet, measuring things like land cover, ocean temperatures, and atmospheric changes, all from space, without ever making direct physical contact with the Earth's surface.
To take those vital signs, satellites use 2 totally different types of sensors. Passive sensors are exactly like your own eyes. They can only see when there's light, detecting sunlight reflected off the Earth. But active sensors, well, that's where the real magic happens. They emit their own energy, kind of like radar. They send down a signal and measure exactly what bounces back. This gives us that true X-ray vision I mentioned earlier. Active sensors can pierce right through heavy, dark clouds. This is an absolute game changer for monitoring environments in cloud-covered regions, like Bangladesh during the heavy monsoon season.
Now, what's really interesting about this is how we apply all this satellite data to everyday life. Take the urban heat island effect. When we look at rural areas, they naturally cool themselves, but the dense concrete infrastructure of a city, it absorbs and traps the sun's heat. It's exactly like wearing a thick black shirt on a scorching sunny day. You're going to heat up way faster than someone wearing a light, breathable fabric. When mapped out, places like Dhaka show distinct bright red and orange zones where this heat is becoming dangerously concentrated.
So what does this all actually mean? Because of this urban heat island effect, the city of Dhaka experiences a staggering temperature difference of 3 to 6 degrees Celsius compared to the surrounding rural zones. This isn't just, slightly warmer. It's a massive, life-altering increase that causes heat stress and skyrocketing electricity demands. And GIS shows us exactly why it's happening. Uncontrolled urbanization, the destruction of natural wetlands, and severely reduced green spaces.
But heat isn't the only extreme we are dealing with. Let's talk about water. In highly flood-prone countries, spatial analysis is literally a lifesaver. By capturing satellite data that highlights flooded areas, GIS allows governments to essentially connect the dots across the physical landscape. They can see exactly where the water is accumulating, how it's moving, and use this real-time spatial mapping to design absolutely critical flood risk management policies.
To accurately predict where these flood risk zones are going to be, analysts don't just look at a single picture. They use a brilliant GIS technique called overlay analysis, stacking specific data sets right on top of each other. Step 1, they take satellite imagery to see current water bodies. Step 2, they layer on digital elevation models, which is raster data showing the exact height and slope of the terrain. Step 3, they add hydrological models to simulate how water will flow downhill. When you layer these three things together, you get a highly precise map of exactly who is most in danger when the heavy rains come.
Once we know where the risks are, how do we actually plan for them? We use a super powerful GIS tool called buffer analysis. Think of this as drawing a strict personal space bubble around an important geographic feature. For instance, you could instruct the software to draw an invisible 2-kilometer shield around a major river. By doing this, the GIS immediately highlights every single town, road, and farm inside that bubble, identifying exactly what is vulnerable to a flood. We also use this to enforce protection, drawing buffer zones around sensitive environmental areas to keep industrial expansion far away from fragile biodiversity.
Let's move to and see how this builds into global conservation efforts. By constantly comparing satellite imagery over long periods, GIS allows us to monitor global deforestation with incredible precision, identifying persistent forests, pinpointing massive forest loss, and even tracking forest gain. This is exactly how we keep a watchful eye on some of the most vital ecosystems on Earth, like the beautiful Sundarbans mangrove forest, tracking its health from space year after year.
And monitoring these forests is super urgent because they face severe compounding threats. We're talking about rising sea levels creeping into root systems, rapid industrial expansion swallowing up land, and devastating cyclones tearing right through the canopy. Using GIS, scientists calculate specific vegetation indexes, like NDVI, which measure the exact greenness and health of the plants. This lets us monitor these specific threats over time, seeing exactly where natural habitats are losing ground right down to the specific pixel.
So why does all of this matter to you right now? Because we are standing on the edge of a massive technological leap called GeoAI. This is the integration of all that spatial data we've been talking about with the predictive power of artificial intelligence. By combining GIS and AI, we aren't just looking at what has already happened. We are building advanced climate models and doing smart city planning to predict disasters, deforestation, and urban heat crises before they even happen. It is taking our superpower and literally giving it the ability to look into the future.
Which brings us to our final thought. The Earth's climate is changing rapidly, but as you've seen, we are not without tools. You now understand the components, the data, and the methods of this incredible framework. The oven is hot and the ingredients are totally ready. The real question is, with Earth's climate changing so quickly, how will you step up, put on the apron, and use spatial thinking to protect our future? I really hope this explainer sparked some ideas for you. Keep thinking spatially and stay curious.